Exercise 5C, exponential equations. Today we're learning about simplifying and solving exponential equations. What you need to be able to do is recall index laws, apply index laws to exponential equations, simplify exponential equations, and then solve exponential equations. So to start off with, these are your index laws, which you've been learning since about year 9. So just very quickly reviewing it, if you've got the same base and you multiply, then what you can do is add the powers. Likewise, if you divide, you subtract the powers. If you put a power to another power, so with brackets, then you multiply them. Anything to the power of 0 is equal to 1. You can change anything with a negative power to the other side. So if it's negative on the top, then you can take it to the bottom to make it positive. If it's negative on the bottom, then you can take it to the top to make it positive. And that's explaining both of those two laws. So hopefully we're across all of that. And now we're just going to go ahead and apply it. So this is very much a review exercise. This one says solve for x in each of the following. So whenever we're solving for x, the easiest way to do it is to consider having the same base on both sides. If you have the same base on both sides, then you can equate the powers. So here I can see that I've got a base of 4, and here I've got a base of 1. Now, my question is, can I turn this 1 into a 4 to the power of something? And yes, I can think about the index law that says a to the power of x, or rather, sorry, a to the power of 0 is equal to 1. So I can rewrite this as 4 to x minus 2 is equal to 4 to the power of 0. And now because the bases are the same, I can actually just equate the powers. So that'll be 2x minus 2 equals 0, 2x equals 2, x must therefore equal to 1. We'll try that same idea here. So I can see that there's a base of 3, and I'm wondering, can I write 162 as a base of 3? Probably not yet, but what I can see is I first need to get rid of that 2 anyway. So what I'm going to do is I'm going to divide both sides by 2 first, and then I'll think about the base of 3. So 162 divided by 2 is going to be 81, and then I'm going to think about, can I write 81 as a base of 3? Which I can. That should be 3 to the power of 4. Now I can easily equate the powers, so that'll be 3 to x equals 4. Next one, same idea. So base of 5, base of 125. Can I write 125 as a base of 5? I should be able to, so that should be 5 to the power of 3. Now, what you need to make sure is that because I've already got a power of 2n minus 1, I need to write that in brackets. So I'm going to need to multiply those values out. And that's equal to 5, 3 minus 4n. Now that the bases are the same, we can equate the powers, and I'm just going to expand at the same time as well. Get all the n's on one side, all the numbers on the other, so it'll become 3 plus 3, and then divide both sides by 10, which should give you 3 on 5. Next one. Now, this one looks like a quadratic. So you can see that you've got, well, it's not necessarily a quadratic itself, but the idea is that you've got 2 brackets that are being multiplied, and that's equal to 0. So in this case, we're going to use the null factor law. So if I have something multiplied by something else and it equals to 0, that tells me that either A has to equal 0 or B has to equal 0 or both. Otherwise, we will not be able to get the value of 0. So I can apply the null factor law in this case and start solving. So 2x equals 16 and 2x equals 4. I'm going to rewrite the bases. So I can write this as 2 to the power of 4. That's what is 16. And x would be 2 to the power of 2. And now I can simply equate the powers. Okay, so I get x is equal to 4 and x is equal to 2. Now, how did we get to this previous stage where it's nicely written in brackets? It actually starts off with a question like this. So you need to be able to recognize the fact that this looks like a quadratic, and I'm going to apply quadratic properties to it. The key thing to remember is that there are 2 x's, 1 x, no x. So I will always think about 2x, 1x, no x, kind of like a quadratic, right? So 2x, 1x, no x. So we're going to apply quadratic ideas to help us solve this. Now, there's a very specific technique where, to just simplify my life, I'm going to let a equal to 3 to the power of x. Now, 3 to the 2x can kind of be written like this. It's 3 to the power of x and then just squared. Remember, when you put a power to another power, you multiply it. And the reason that I've just rewritten it like that is because 3 to the power of x I've just defined as a. So that would be a squared minus 12, that's 3 to the power of x, so that's just a, plus 27 equal to 0. And now I do have a nice little quadratic that I can solve. So I need two numbers that will multiply to give me 27 and add to give me negative 12. So I'm thinking of 9 and 3, and because the 27 is positive and the 12 is negative, then that means they will both be negative. So I'll have minus 9, a minus 9, and a minus 3. Okay, and then I can solve that. So that'll be a equals 9 and a equals 3. But of course, we're not solving for a, we're solving for x. So at this point, I'm going to replace that into here. So I will have 3x is in fact equal to 9, and 3x is equal to 3. Now what I can do is change the bases. So 9 can be written as 3 squared. 3 is just 3 to the power of 1, and I can equate the powers. So this is a very specific technique that you need to remember and recognize. So again, 2x, 1x, no x. That's what you need to think of. As soon as you recognize that, we let a equal to whatever the base is to the power of x, and you can carry out the technique from there. Now this is a very similar one. It's just written on two sides. So first thing I'm going to do, well, I can kind of do two things at once. First of all, I can take everything over to the other side to make it equal to 0. And secondly, I can recognize I'm going to have to use the same technique because I've got 2x, 1x, no x. So I'm going to let a equal to 3x once again, and at the same time, I'm going to take everything over to one side. So because this is two x's, but a is only 1x, so this is going to be 3a squared minus 28a, minus because I'm taking it over, and then plus 9 because I'm taking that over too, is equal to 0. Now for this one, we need to think of a number, two numbers, that multiply to give us 3 times 9. So remember, when it's a non-monic polynomial, and then that needs to add to negative 28. So I'm thinking negative 27 and negative 1. That's the only way we're really going to get to negative 28. Because it's non-monic, we do need to split the middle term. So we'll have 3/8 squared minus 27a minus 1a plus 9 is equal to 0. And now we can factorize by grouping. So I can pull out the 3a here. I'll end up with a minus 9. And here I can just pull out the negative to result in a minus 9 as well. Now, because these two brackets are the same, I can now factorize that out. So that's a minus 9. And what I'm left over with is 3a minus 1 is equal to 0. Okay, now I can solve it. So that'll be a is equal to 9 and a is equal to 1/3. But of course, I'm not looking for a, I'm looking for x. So at this point, I'm going to resubstitute 3x into my function. So we'll have 3 to the power of x is equal to 9 and 3 to the power of x is equal to 1/3. And now I simply need to rewrite it as the same base. So that'll be 3 to the power of, not 3, 2. And 1/3, remember, when we take it to the other side, we just need to put it to a negative power. So that'll be x equals 2 and x equals negative 1. So a little bit more involved, but that's basically it. All right, that's it for this exercise. Enjoy.